Good afternoon. I can't believe that construction technology is not as popular as Google. Can someone shut the doors? So thank you very much. My name is Dan Hughes. I'm Director of Data and Information Products at RICS. I also lead a piece of work looking at how technology is going to change the sector. And so we're going to focus on construction here, and we've got a great panel to talk to you about it. But what I want to do is really look at it in two different ways. So firstly, have a look at how construction is taking on technology, what's happening from that point of view. But also, and possibly more importantly with a lot of the audience here, is how does that then feed through to the rest of the life cycle? So I'd certainly encourage you to please put your questions on Slido, which we'll be using, and look forward to getting this going. So we've got a great panel. I'd like to start with introducing Yodit Stanton, who is the founder of OpenSensors.io. Next, we have James O'Donnell, who's a senior structural engineer at Arup. And then finally, on the end, we have Ed Bartlett, who is CEO and founder of Kykloud. Ed, perhaps I could start with you. Maybe you could say a few words about you and your company's role, and also what you think is going on from the construction side.
So, probably the most interesting thing that we see is that we're very much looking at existing buildings and existing assets, but what we're increasingly finding is that we're picking up from a construction project, or the end result of what we do ends up in a refurbishment or a construction project. So although we've focused on existing buildings, had to get our products and technology to be able to work in construction and interface with the construction process. So what we've seen with building information modeling is probably the key game changer over the last 2-3 years. And I think in particular what's happened in the public sector and what's happened with government agencies adopting building information modeling, and that's really been, it's almost been top-down driven, sort of by policy, but it's really seen a transformation in how that technology moves across the industry. And I think we've in the same way we talked earlier today about integration of technologies, we see the integration into construction as probably the biggest immediate opportunity, because buildings are being built at a rapid pace using BIM right now, and there's an opportunity to tie into that.
Great. James, same question to you.
So I'm a structural engineer in our London office. I spent the last 5 years working in our Melbourne office, leading a design and digital innovation team, looking at how digital technologies was going to disrupt the way we deliver a project to the built environment. So in a kind of project lifestyle, the construction part of it is expensive and risky, and we kind of deliver things in 3D from the modeling point of view, then we turn it into 2D drawings, and then we deliver it to site, and then it kind of all goes pair, kind of square, and who knows what happens in terms of delivering it, collaboration, working with things like AECO and Revit, Triple Connect and Celebri around clash detection, and understanding the risks and delivering a project on time. So looking at kind of virtualization of the construction timeline, so actually delivering what we design as architects, engineers, fabricators, to kind of de-risk the program timeline, and then ultimately put some sensors in our buildings and bring that back into the front end to learn how we can deliver different solutions for next generation of buildings.
Okay, great. Yodit, same question to you.
Hi everyone. So my background is machine learning and data. So I'm a data engineer by kind of over the last 15 years. So I'm very much bringing kind of like a technology context. But so Open Sensors has been around for about 3 years. Most of our clients are within the kind of commercial real estate space, and we tend to work with architects, workspace designers, and the occupiers, who are deploying lots of sensors. So from the architectural point of view, really what the trend we're seeing is people using a lot of this data to inform design. So, kind of, obviously previously, you all know that, people were using a lot of manual surveys, also a lot of gut feel in terms of the redesigns, what is necessary for the next stage of either the refits or actual kind of complete redesigns. So essentially we're a sensor company. We deploy kind of usually kind of fit for environmental sensors. Other things that we're seeing a lot of is people thinking a lot about how they're going to meet the kind of well building standards. So thinking very deeply in terms of continuous monitoring of air quality. And we test a lot of these kind of sensors. We're not a hardware company, but we spend a lot of time testing the hardware, the data quality, and then kind of the analytics side. So that's where we sit in terms of this market.
Okay, great. So can I just ask a show of hands? Who's heard of BIM? Is anyone? Okay, a reasonable amount. So I just wanted to pick up on BIM. So for anyone who hasn't heard of it, it's Building Information Modelling. And it's something that was mandated by the UK government for all of their construction projects. About a year ago that came to force, so April 2016. And Ed, you just touched on BIM, and then James, you've spoken about the virtualization, and you can create the models, but then it goes onto paper. Ed, we've had previous conversations about the adoption. Just wondered if you could say a few words about BIM generally, but specifically how we're doing with adoption of that.
Yeah, certainly what we're seeing is BIM probably is almost the rule. It happens on projects of a certain value. I think that there is almost a trigger point in construction value. I wouldn't like to say exactly what it is, but typically projects over the 50, 60 million, 100 million category seem to be where BIM's really focused at the moment. But I do see that, the opportunity is growing, particularly in the housing sector, and it's being looked at on smaller scale projects. But it tends to be big project world at this point in time, and I think that makes it interesting to the larger contractors. It makes it interesting to large scale clients. But I think what the feedback and the messaging that we're seeing is that lower down the supply chain and small and medium sized projects and operators, there's still a gap of understanding and a gap of adoption. And I think there's a lot of effort going into to address that, but there is definitely adoption, but it is big project world at this moment.
James?
Yeah, I think similar in terms of the project lifestyle, the kind of life cycle. I think clients aren't engaged as much because the way it's set up at the moment is it's quite clunky and difficult to open the engineering and architecture and fabrication process. Because Revit, for example, is quite difficult in terms of being very open and easy to use. I think we need more platforms where we can get very easy searchable data on our projects and be able to open up and really kind of look into see how we can streamline the construction phase.
Okay, so we've had a question come in that's saying about uptake for BIM level 3, I think that's what I was asking for. So the government mandated BIM and they explained various different levels, and it was level 2 that was mandatory for about a year ago. And this is asking about BIM level 3. Is that a long way off for the industry?
It is a long way off because we're not at BIM level 2. People say we're at BIM level 2, but if you actually go around and if you had, for example, a BIM maturity matrix, if we have a level setting where people go in and say, honestly, hand on heart, where they are in terms of what they're delivering in terms of federated model, that, for example, at the moment, typically, your structural engineer, your mechanical engineer, your architect all work in separate models. You're lucky if it's always 3D. In Arup, we've mandated 3D, so we go kind of full steam ahead. We're still working with lots of consultants working in 2D. Once you get to that point, you then deliver your model to a fabricator who basically builds their own model and starts again, and then, like I said, goes into drawings. If you go into BIM level 2 and you kind of Google it and you go into the past documentation, whether it's the English version or the American version, you very quickly get down to a dead end and a bit of a headache as to what it's actually asking you to deliver and how you can deliver it. So I think there's many different interpretations of what BIM level 2 is, let alone level 3. And I don't think if we're honest, we're even at BIM level 2. Okay,
thanks. So I agree. So one of the things you said earlier was about putting sensors in buildings and learning from that so you could then do it again. So Yodit, your business is really focused on the sensors, gathering the data so you can benchmark, learn and inform design. So maybe you could just say a few things about how that data can be used for long-term construction design in the future.
Yeah, there seems to be, I think there's stages of kind of these sensor deployments that we're seeing. So there is at the early stages, obviously the landlords are putting in a lot of the early sensors. Possibly now we're seeing a lot of kind of trends towards smart lighting and so forth. And that kind of data goes into 1 or 2 systems. And then people like us come in, and usually kind of we're coming in during the fit-out stages when the occupiers are coming in, and when we deploy sensors. And I think one of the problems we're seeing is obviously kind of we're trying to the way we work is we kind of enable open APIs and really are trying to integrate with as many of the existing systems as possible, but not everyone's doing that. And I think it seems like quite a lot of waste in a way to kind of having to redeploy sensors to get one set of data when actually a lot of data sets exist already. So what I'm hoping for over the next kind of couple of years is this effort in easy integration, and it should be plug and play, and it's not yet. So ideally that's where we should head.
And James, anything you want to add on to that, and not so much about how you collect the data, but how you then use that to inform future construction projects?
Yeah, I mean, a lot of designs now are driven by standards. Some of the standards were written in the 70s, 80s and 90s. And often what happens is we over-design our buildings, whether it's when you're designing the number of lifts in your building and waiting times. It's based on the kind of percentage of occupancy in the building, how many people, how many minutes you're going to be waiting. But realistically, as we move forward, will more people be using stairs? Would less buildings be less occupied because there's more hot desking, or the whole WeWork thing might mean it goes the other way, and actually they get higher occupancy rates. So sensors will allow us to get that real-time feedback into delivering projects, but at the client's risk. So if you move away from the kind of BCO standard of delivering an office spec building because your sensors are telling you otherwise, that risk has to lie with somebody. So that's probably what maybe is one of the stumbling blocks is to getting it over the line.
Okay, great. So a couple of different questions which I'm going to combine here. So one is about 3D printing as a viable way to innovate in construction, and the other one is the best technology to reduce time and costs in construction. So maybe I could put those two together. And Ed, any thoughts on that?
Yeah, I mean, there's been some really good examples of 3D printing applied in construction. There's a project out in Dubai that recently completed, which has drawn a lot of attention. And and I think so. This links into some of the other sort of questions around what's the viable technology today, and 3D printing has a real place because it also deals with some of the health and safety issues, and it deals with some of the efficiency issues that the construction industry is looking to achieve. Whether it can be rolled out from a scale point of view is another question. There have been quite small and sort of cleverly designed projects that it's been applied to, but it is happening, and the examples are there. And I think in some ways that's actually accelerated past some of the sort of more mainstream things that are happening in BIM. I think 3D printing's really pushed ahead, but I do think that technology is pushing ahead because it's got that robotics and sort of hardware piece to it. It's almost taken the human out of the equation, which is a shame because it suggests that it's the human that's slowing down the innovation in BIM as a general theme. So I think more robotics is the answer in terms of efficiency and tools. And there's some great examples of robotic applications in building brickwork. I mean, brickwork can now be built through robotics. It's tried and tested and has been rolled out, and I think that's really interesting because that's taken us into a different world, and you want to start to remove the need to be concerned about some of the construction quality issues because they've been dealt with in an industrial way. But yeah, I think it is an alternative. It's viable.
So an awful lot of technology, offsite 3D, BIM to a degree, is all about quicker manufacturing of buildings. James, the cost isn't always lower in itself, but the speed itself can actually mean that you can get the building much quicker. I was just wondering if you've got any reflections on whether clients or end clients are starting to look at that overall cost basis.
Yeah, certainly are. And one of the questions was alluding to what kind of 3D technology, what technology can deliver the best cost saving. It's got to be kind of 4D BIM in the sense that you're kind of program managing and building virtually the building before you even go to site. So you can see your clash detection, you can understand your safety risks, you can understand where you'd like to be held up, and you can actually build it and kind of get those stumbling blocks ahead of you before you actually get to site. And there are real big advantages of that, and we're seeing big savings.
Okay, great. Yodit, anything from your side on the manufacturing, in particular 3D printing?
Not as much considering you said.
That's a fair enough answer. Okay, so
I was going to say just quickly on that, in terms of going back to my last point about BIM level 2 or BIM level 3, having a federated model, i.e. everyone working in a live model which is kind of ready to be clash detected, is really, really powerful, and I think that is where we need to be heading. And understanding in terms of what PropTech, what those tools can be to deliver that to our industry.
Yeah, okay, so that's a great point. So following on from that, the live model that you were talking about, there's a question that's come in here about, I won't have to all of that out, but it's about the BIM model, is it actually built that way? So it's about whether the original BIM model stays current or not. Do you have any views, Ed, on how you keep that up to date?
Yeah, well, I mean, there's one of the early questions looked at this point about open BIM standards and being able to link together modelling, and I actually think that without, you know, we can be, BIM's done a huge amount in the industry, and it's achieved a lot, but it's also had a lot of internal criticism from within the industry because it's perhaps not delivered what everybody wanted to deliver quick enough, and that you know, when you innovate, you always leave, you know, you're on the bleeding edge a little bit. But what we can see is one of the real fundamental benefits that we can't overlook is around data standards and data structure, because without the common data standards and common data environments, as they're called, and the ability to link an architectural model to a building fabric, to a mechanical model, to an externals, the fact that you can federate them and overlay them on top of each other, you know, models that have been developed by completely different consultants being pulled together and viewed as a whole, that's pretty clever stuff, you know, and that's probably the bit of innovation that people overlook, and that's where the most of the benefits coming at the moment in terms of, and that from an operating, you know, from a client point of view, being able to take that complete data set and push that into facilities management, push it into property management is a huge innovation, a huge benefit. And I think that's the piece that we should still be focusing on. I think we've tried to jump ahead and try and do too many things with it. Let's capitalize on those benefits, and you know, and I think getting the whole supply chain working in an integrated way probably is the biggest opportunity, rather than trying to address, you know, level 3, level 4, whatever the next level is. Let's you know, consolidate on the benefits that we've achieved. And I think some of the technology that's out there, they're pulling the, you know, there's some, you know, some of the Autodesk and Bentley products, huge data engines, really powerful software products, and you know, the skills that are coming out of the industry, you know, people coming out of university with the ability to do 3D modelling from day one is a massive step forward. I mean, and you know, I think there's some real positives there.
And there's a note about construction workers aren't university diploma holders. Yeah, fair point maybe. But also, we're finding that the virtual reality design review is real and is happening. We've got a site where just over the road, we're bringing the construction team and the client into offices, putting the headsets on, and actually looking around the building, around the tricky bits we're constructing, to kind of talk through the process, talk through what the risks are. And I remember 5 years ago saying, oh yeah, everyone's going to have iPads on site. And people saying, no, you know, you need the A0 prints folded and, you know, rain all over it and dripping away, folded into your back pocket. It's gone away. People are there with iPads, and they're looking at reinforcing drawings, they're looking at assessing out drawings with iPads, and you can scan around and see where you are. That's not just a faff anymore, or a fad, that's real. We're definitely moving there, and it's quite exciting to be in that kind of arena.
So we've spoken a lot about new construction projects, but I wanted to touch on existing buildings, which is often a lot of the construction side of things. Yodit, you put a lot of sensors, I think, into new build, but in particular into existing buildings. I wonder if you could just talk about some of the challenges that you face retrospectively putting in that technology.
Yeah, I think the first challenge is what I think people get very, very excited about gathering data from you know, the kind of the possibilities of when these sensors come in life. I think people that haven't done any sensor projects, things that they don't consider is the maintenance. So these are usually battery operated. There's some connectivity to the internet. So how's the kind of the design of the network going to work? And again, there's also you are deploying, especially, you know, within normal buildings, you're potentially deploying thousands of sensors. And this is yet a new asset that is not necessarily being tracked as an asset within the building. So in terms of projects, I think the way I like to do it is usually say, like, just do a contained thing within, you know, a small space. Get your head around the networks, the management, who's going to install it, who's going to change the batteries if things fail. And then there's obviously another skill set, which is, kind of data side. A couple of the architects that we're working with are now starting to hire data scientists in-house. And so they're really starting to think about changing the way they work. And I think that's really interesting to me because the workflows of the architects, they're not just going to kind of design something and leave it. They will be engaged with the space, and because it will be, I suppose, a live system, as it were. So that will be very interesting in terms of how people's workflows change.
So that's great. Just staying with the point you made there on data. So throughout pretty much all of today, data keeps coming up as an issue or a topic. Do you have any views on who owns that data and the IP around it? There was also a question earlier about ownership of 3D data, I think it was, in there as well.
Yeah, that's a really good question. I mean, from my point of view, I think that anyone that deploys the sensors owns the data. They usually paid for the sensors and invested in the kind of the work and the rollout. But there is an interesting tension between the different stakeholders, and right now what doesn't exist within the industry is the ability to share data between the stakeholders, between the landlords, the tenants, the kind of managed service providers. And they don't need to see everything. I think but there is no framework to do that yet, and I hope to see that at some point, because there's just so much data there already, and it's a shame when people have to kind of reinvent the wheel every time they need to start some projects.
Yeah, great. So there's a question that's come in that's at the top there, and James, if I could start with you on this. That we spoke about BIM as being adopted or it's not, but there are different views on it, but there's a real focus on the big companies all of the time. Do you have any views on how the smaller companies can cost effectively buy into this and the implications for them?
Yeah, the guys next door to my house are building a loft conversion, and we had this discussion. I sit on a panel about digital workflows and kind of for structural engineers, and there was the same question about it's only, all this digital stuff is only for the big companies. And I asked to see the calculations because I'm fussy and it's kind of what I enjoy. And I was blown away by the fact they had a proper 3D model, and all the design calculations were done automated and delivered as a kind of automated printout. And I kind of realised, well, actually, they have to do that now, because you can't get away with doing lots of hand calculations and starting from fresh. Small companies have to innovate as well, because in terms of delivering a solution, they need to be able to be at the kind of market leading kind of edge. So I think, although the large companies have maybe the money to invest in these systems, we're seeing smaller companies come along and compete, whether it's millennials saying we can deliver an online engineering service, or I remember we were in Melbourne and I was getting our car fixed, and the guy who was leading the kind of mechanic place, he was on his laptop at the back, and I said, "Oh, what are you working on your laptop?" And he was doing the MEP Revit design for like a 10-story residential building in his spare time, because he could do it for cheap. He had no rent. And someone had approached him, and he was skilled up, and he could deliver it. So I think there's opportunities for everyone.
Okay, great. James, just sticking with you, specifically picking on the structural engineering elements of this. There's a great question.
Smiling. It sounds like you were coming with a preloaded
No.
question.
So there's a great question here about the new manufacturing techniques generally, or building techniques, but it's looking at 3D printing, modular construction, and so on. They're great. They're quick. They can get to sites. They can sometimes save money. How do we actually know that they're sustainable from a structural point of view and building life cycle?
Well, modular construction is fantastic. I think it's proven. So I think that's kind of almost part. And earlier on, there's some talk about the private rental sector and literally throwing up these buildings in 3 to 6 months rather than 3 to 5 years. There's your return on investment. You can get out of the ground, building up and away, and you've saved 2 years of your construction program because you've modulated it, and you can then take that and use it in a different city or a different country. I think there's this age-old discussion about why can't we be like the manufacturing industry or like the car industry, automation industries, because often we work where we think we can reinvent the wheel every time, and we come to a new project, a new building, we go, right, we're going to do it from scratch, we're going to do a new design, new way of building it. But actually, if we can maybe automate that process and still deliver some really nice efficiencies and some bespoke aspects of the project, but deliver a modular construction, then everyone's is a winner. On 3D printing, it's a really, really wide topic. I've led a couple of research programs in Arup where we've looked at 3D printing steel connections for, like Singapore Sports Hub Stadium. And okay, we're not there yet, but maybe 5-10 years we will see genuinely a printed, maybe less than that, printed node in steel in a large scale building, because you get the confidence of the complicated connection designed by the computer, checked and verified, but also it saves weight, saves tonnage, saves programming on site. So we might not be there yet, but in terms of 3D printing, it's going to come at us fast.
Great. So Ed, perhaps I could ask you a question. I know that you've got a case study that is close to my heart, certainly. But maybe looking at BIM and what we're talking about construction, but specifically for existing buildings.
Yeah, I think we've seen, in the last year, we've seen around probably 15 examples of really good examples where BIM technology has been used to survey, well, it's a combination of BIM technology and survey technology, to survey an existing building and from that build a 3D model of that existing building. An example that you mentioned was actually the RICS headquarters in Parliament Square, listed building, quite a complex building, probably one of the most complex buildings I've seen in terms of roof structures and complexity, and that, it was done as an exemplar project to a certain extent, but we then were brought in, and I think the survey was done by a company called Seven Partnership. One of our other clients, a surveying company, was Trident Building Consultancy, were brought in to do a condition survey of that property, and we almost didn't expect to get any real value from the BIM. We didn't know if there's going to be anything in that would help us undertake a condition survey and generate a forward sort of property investment plan for the client. But we did a little bit of R&D with it, and we found that there was real benefit. So, for example, in preparing for a survey of an existing building, a building surveyor would typically get a set of drawings and do schedules of rooms and generate information to feed into the survey. So the first benefit is we were able to download and pull an up-to-date and accurate schedule of rooms from the information. We're able to pull across specification information. We're able to pull across, and even to the point where we had a pre-meet before the survey team went to site, we were able to walk the survey team through the building in 3D, so that when they turned up on site, they knew where to find things. They knew the configuration of the building, and those little things which actually, they all save time on site. They all save, we worked out, we probably saved 3 or 4 hours of time by able to link in the room data. We probably saved a little bit more time around pulling specification information. So say we saved 10, 12 hours of time, that's that's real cash to the parties involved. So I do think that's becoming more mainstream, and we saw an example of that at an airport project recently as well, where they were looking at doing a refurbishment, refit of basically a connection wing to the departure gates and rather than just do a design, they undertook a condition survey, linked it into the design of a BIM visualization, which allowed them to get the right combination of condition upgrade works versus just refurbishment for improved flows of people and the use of the space. So